We are going to be doing, this lesson is about similar figures. And this is very, very similar to something we've already done, but in picture form. So what I'm going to do is review some of the old lessons, and then we're going to do this exact same thing, but with pretty pictures. All right. So similar figures is just like some old lessons, but with pretty pictures. All right. So we're going to start by reviewing old lessons. And then the stuff that we're going to do today is just like those, but like I said, just with fun, pretty pictures instead. The first one was from 5-3. And this asked this question, are they proportional? And it would have something like this. 5/15 and 4/12. And I don't know if you guys remember this, but we had 3 different ways to solve these. Right? We had 3 ways to solve. Anyone remember one of the 3 ways? Let's see if we can. Yeah, Sophia. So one way was cross products. That's right. Here, we'll just solve it out, and then we'll get to the next one. So like the cross products way, and we're going to solve it out 3 different ways, would be 5 times 12. Oops. And 5 times 12 is 60. And then 4 times 15. And that also equals 60. So the answer to this is, are they proportional, is yes. So the cross products way, if they multiply to different numbers, then it's no. There's a second way that we could do these. Anyone remember a second way? Yeah? Yeah? We can reduce them like fractions. Again, let us reduce it, then we'll go to the last one. 5/15 and 4/12. So we could reduce these. This would like reduce down to 1 and 3, and then 1 and 3. Since they reduce to the same thing, our answer is still yes. Right? If they reduce to different fractions, then our answer would be no, or different ratios, our answer would be no. There's a third way. Can you remember the third way? That's right, the relationship way. 5/15 and 4/12. And this would be like this, times 3, right? Times 3. Since they multiply by the same number, our answer is still yes. Now what we're going to do is take this lesson, are they proportional? And 5-5 is going to do, the section that we're doing now is doing that, but with a fun, pretty picture. And now the question is not going to be, are they similar? Or excuse me, are they proportional? It's going to be, are they similar? Similar is just, it's like the geometry version of asking the same question. And now it's going to have, like I said, a fun, pretty picture with it. So we're going to draw 2 right triangles. And the right triangles are going to be different shapes, or different sizes, excuse me. And we have to think, are they similar? What it means, if something is similar, it means that they're the same shape, but a different size, like a miniature model of something. And so what we're going to do is set up proportions, and we're going to, the only difference is, see how this stuff, it tells, like it gives you the 2 proportions. You have to set up the proportions in these ones. So it'll be something like this. It'll say this side here is 3, and this side is 12. And then this side here is going to be 5, and this one's going to be 25. So we have to set up a proportion The key to this, like we've done in the past, is we have to make sure that we make junk match. So it's like I can have the left side over the bottom side, right? Left side over bottom side. Now, if I did 3 over 12, for this other triangle, what matches with the 3? The 5. The 5 has to be on top because it matches. All right, and then what's on the bottom? Now we're going to solve this the exact same way. You can reduce them like fractions, you can do cross products, or you can find a relationship. Anyone out there think that they can solve this one? Yeah? So, okay, you're going to reduce them? I'm getting confused what you're saying. I'm going to go a different way. I think you got the right answer, just kind of confused. Yeah, Kian, what would you do?
I would reduce them.
Okay. Uh-huh. So are they similar then? No. The answer is no. Right, you could do any of them. You could do cross products if you wanted to. You could do a relationship, right? Like this is times 4 and times 5. Since they multiply to different numbers, the answer would still be no. But see, the difference is you have to set it up. It's the same thing, but with a pretty picture. That's it. All right, now I'm going to give you, our notes are going to be longer because we're like doing notes and homework all in one right now. All right, so it might not end up being like 2 pages worth of notes because now I'm going to do some more example problems because you already aren't going to do this for homework. So, all right, let's have you guys do a second one. You're going to answer, are they similar? And now I'm going to do rectangles. And then a smaller rectangle. And this side is going to be 4. And this side's going to be 20. And this one's going to be 1. And that one's going to be 5. I want you to set this up and then answer the question with either yes or no. And then you're going to show your work by one of the 3 ways: reducing it, cross products, or showing the relationship. Go for it. Try it out on your own. All right, compare what you got with the people around you. It's okay if you're not done. Go for it. Compare what you got with the people around you. Ready, set, go.
Did you get times plus? Divided by 4. Divided by 4. You mean divided by 5? Oh, yeah, that works too. Oh, yeah, I see now. Okay. And you got yes? Okay. Yeah, I got yes too. Yes.
All right, let's go over this. So we can set this up like this. 20 over 4. And it's okay if yours looks different. It just has to match, right? Like the 20 and the 5 should be in the same spot. And the 4 and the 1 should be in the same spot. And then there's more than one way you can do this, right? Like you could think of it like this, times 5 and times 5. There's other relationships you could do, and if the relationships don't work, you could do cross. There's a whole bunch of different ways you can do this, as long as you got yes, they are similar. We're going to try to do another one, and this one, I'm going to try to be tricky. Tricky, tricky, tricky. All right, be careful. This one's going to be tricky. All right, number 3. Are they similar? We're going to draw a right triangle like this. And then this one's going to be 3, 4, and 5. Now, watch this other right triangle. We're going to draw it like this. So the right angle, it's like twisted a little bit. And then this is going to be 8 and 10. And we'll do all of them, 6, 8, and 10. Now, here's the thing. You have 3 options. You don't need to use all 3. You don't need to. You can just pretend that some of them aren't there, but you got to make sure they match. All right? So it's okay if you just pretend that one of the sides isn't there when setting it up. When you guys compare them with each other, you might have different things set up. That's okay. Go for it. Try to set it up on your own. Again, be careful because I spun the triangle around. Actually, not only did I spin the triangle around, I also like flipped it upside down. It's like spun and like it's like a mirror image and spun around. So that's a little tricky. All right, work with the people around you.
When you said make sure they're matching, I used the bottom one and the left one. So I got 3/4 and 6/10. And then I reduced them 3/4 and 4, and then 6/10 is 3/5. And yeah, the answer is no. Did you get those?
I got yes. No. I got
I got 10 and 12.
Can you flip it?
I got 3/4 and 6/10.
We've always been doing that.
Yeah, there's probably different ways. You gotta know. But that's the most
No. Ella, what's your answer?
No.
You guys need more time? All right. Here's the thing about this when you're setting this up to make a match. You should think of them not as like left, right, up, and down. Think of it like the small side or the small leg, the medium, right? Like the small, medium, and large. Right? Small, medium, and large. So like if I did this, 3 to 4, what would be the ones that match with 3 and 4? What matches with 3? 6. And what matches with 4? 8. Do you guys see that? So you should think of them not as left and up and down, but like the small side, the medium side, and the big side. Now, is there a relationship here with this one? Yeah, it is. Times 2 and times 2. Our answer is yes. That is as tricky as it can get when it spins the shapes around. There's not going to be many of those. The second thing we need to do that we're going to, actually, we're not even going to review it because we'll just talk about it now because it was just like, now we're going to do the same thing that we did in our bell work, except fun, pretty pictures of our bell work. So it's the exact same, but with fun, pretty pictures. You guys ready? It's going to look like this. The instructions are going to be find the missing side. And so now it's going to say these two shapes are proportional. You've got to find the missing side. So it'll have something like this. We'll do with rectangles here. This side is going to be 6. And this one is going to be 36. This one is going to be 4. And that will be X. You have to set up the proportion. So the difference is in the bell work, it already gives you the proportion. This one, you've got to set up the proportion. All right, let's see if we can get this to match. 6 over 36. What matches with the 6? 4. And then what matches with the 36? X. There you go. Now you can solve this by doing cross products or a relationship. Anyone see a relationship there? Yeah, what is it, CJ? It's got to go the other way. Oh, no. No, you're right. I'm sorry. No, you're right. I'm wrong. Times 6 and times 6. So that makes 24. See, you have to set up the proportion now. So now it's just going to be like the bell work, but the difference is you've got to set up the proportion. All right. I'm going to try to make this one tricky. I'm going to spin it around a little bit. Oh, no. Oh, so scary. So scary. Let's try this out. We're going to do it with rectangles. One rectangle like that, and one rectangle like this. All right. This side is going to be 6, and this one is going to be 18. This one is going to be 15. You've got to find that side. Go for it. Set up the proportion. Remember, don't necessarily think of them as like top and bottom. Think of it as like the little side and the big side. All right. Check what you got with the people around you. Make sure you set up the proportion in a similar way. Go for it.
So I looked at the meaning of the sizes did 18 divided by 3 is 6. 15 divided by 3 is x. So x is 5.
I know the check. No, I know. Are you giving the check? I know what it means. It's like giving like.
Fell down the stairs.
Oh.
Maybe you're not. What?
Oh. Wait. So.
You don't
All right. So again, it's the same thing, just with pictures. I'll do 6 over 18. Which side matches with the 6?
the x.
The x is the smaller side, over 15. This would be divided by 3 and divided by 3. So then x is 5. All right, we've got one more tricky one to do. And this is like a super fun double problem. So we're going to have this 5. Hey, less emotional reactions out of you. Just take the notes. 5, 12, and 13 is one triangle. And now this side is going to be like this. We don't know this side. This one is 24, and we don't know that side. You're going to have to find both x and y. Dun, dun, dun. All right. Go for it. All right, we're running a little low on time, so let's just go over this. A couple different ways you can think about this. One way to do this is just to pretend that the y doesn't exist, and the one that matches with the y doesn't exist. So we could set it up like that. 5 over 12 equals x over 24. And what's the relationship there? times 2 and times 2. So we get 10. And then we can go back and put those back in. And then it's like we can ignore these ones. So we could do 12 over 13 equals 24 over x. And then again, it's times 2 and times 2. And then we would get that this is, what's that? 26. Another way you could have thought of this as well is that you could just realize, oh, look at this. From 12 to 24, as far as the whole triangle goes, is times 2. So then you can just treat each one like its own problem. Well, 5 times 2 is 10. 13 times 2 is 26. Pretty easy, huh? So that's the same thing we've been doing, but with pretty pictures. Because that was so easy, that's it. You don't have any homework to do. We'll review this stuff again later on, but I don't think that's something that takes like 20 problems of practice to do. So enjoy not having homework. We just had the notes for today.